the case, this one is male, there is allele, so therefore this is the a hemophiliac male as well. Okay. Are you okay with that now? I'm going to carry on. So the next thing we are going to look at is pedigree diagrams. When we do a pedigree diagrams, there's certain rules that we follow. Right? There are certain rules that we follow. The rules that we follow is as the first thing you do is you look at your key. So we're looking at the key here. So it says Huntington's chorea is a disease caused by a gene mutation that results in degeneration of brain's allele. Okay? In our key, we see that squares are males and circles are females. So you always look at your key first. Before you even look at the questions, you look at your key first. Okay? So I have Carl, who's a male, and Sarah. But now I notice that there are two types of circles. One is black and the other one is white. And there are two types of squares, a black and a white square. Okay? And I look at my diagram and I see that the black indicates that those are sufferers. The black are people that have the disease, and those that have white circles or squares do not have the disease. So they do not suffer from the disease. Okay? I'm going to just find the page. So, when we do it, I normally will look at the diagram first. And when I look at my diagram, this is what I do. So, I've got my exam paper in front of me, and I'm looking at my diagram, and I see that this is. So, I've looked at solid, has the disease, white does not have the disease. So, in order I know that it is caused by a dominant allele. Did you read that there? So it says, Huntington's chorea is a disease caused by a gene mutation that results in degeneration of brain tissue, and it is caused by a dominant allele. This is very important because we normally used to diseases being caused by recessive alleles, but now we see that it's actually being caused by a dominant allele. So what does that tell me? That if the genotype is this or that, then that person will be a sufferer, isn't it? So the only time that the person is not a sufferer is if the person is homozygous recessive. So a homozygous recessive individuals will not be sufferers. And if I fill in I definitely know that all these individuals can only have this combination because they are not sufferers. Okay? So, as I say, always write on your question paper, first analyze your diagram, look at did you read the question properly? Are you looking at, study the key first. So, because they're saying it is caused by a dominant allele, I know that those without it has to be homozygous recessive. And I can immediately just identify those individuals. Okay. So, because there is two states here, those two states that can cause Huntington's, I don't know whether these individuals are homozygous dominant or heterozygous. I have to figure it out looking at mine. And we always work from back to front. Okay? So, it says, what is Susan's phenotype? So phenotype is, what is her physical appearance? What is the physical characteristic? So she is a female and it's dark, so she suffers from Huntington's chorea. So she is suffering from Huntington's chorea. Okay? The next question is Sarah. Sarah is not a sufferer, so therefore Sarah is homozygous recessive. They want the genotype of Sarah, okay, and not the phenotype. Let's see if who can find 2.4.2 for me. Emma plans to have a baby. What must the father's genotype be so that there is a 50% chance that the child will not have Huntington's chorea? So where's Emma? Emma it is a disease. Huntington's chorea causes the nerve tissue in the brain to degenerate. We did it earlier on as a question also. So what it's like, it's a type of disease. What's the first thing we have to do when we look at Emma? Do we know what Emma's genotype is? Now Emma is the daughter of Susan and Sean. So we know that because she is a sufferer, she must have the dominant allele. Right? SS says, I've got lots of saying there must be homozygous recessive. So Emma, let's see, Emma must have the dominant allele because she is a sufferer. However, because Sean is her father, he can only give what allele? He can only give that to her. Okay? So the father that she marries must be that, because if we do the cross, then we get a 50 to 50% ratio. Okay? So, I don't know if you can see it. Can you see it here? So, this is Emma. This is her husband. In order for Emma to have 50-50, to have children that has this and not sufferers, one comes from the father, one comes from the mother. He has to be homozygous recessive. Do you understand? Because if he was, it would give you 1:2:1 ratio normally. Okay? So then 3 would be sufferers and 1 would not be a sufferer. Okay, so all of you that guessed, explain your answer. Now these are the difficult questions. You somehow find the answer and you know how you got there. But to put it into words on your question paper when they ask you, explain your answer. Right? Who finds it? We all find it very difficult. Now what is it that they want? How must I write it down? I don't know. I know I got it, but I don't know how to write it down on the paper. Right? So you will first say, if you look at the, we find Emma's genotype. Did you see that when I explained it, I first found Emma's genotype? Because I had to know what she had to cross with, right? And then I said what the father's genotype has to be. Now why does it have to be? Because the child will inherit one recessive allele from each parent. Right? So in Emma's genotype will be HH, and the father's genotype has to be small h, and when you cross the two, right, you will get a 1:1 ratio of heterozygous to homozygous, and therefore the child will have to inherit one recessive allele from each parent. Everybody fine with that? I'm going to carry on. Right, here's another pedigree diagram. So it's now on page 23, so we all go to page 23. And I'll take myself quickly out of the stage. I'm going to go back to the answer, okay. Sorry about that. Okay, for those of you that understand, can do the question on page 23 for me, please. And I'll just give those that wants this answer some time. So can you please go to page 23 for me? Okay, Sibongile, just let me know when I can go on to the next page. Thank you. I'm going to ask you, I'm going to give you 6 minutes, 6 marks for 6 minutes, and I'm going to ask you to answer this on your own. Oh, do you break at 12:30? So we'll come back after lunch and carry on from here. Is that okay? Okay. See you then. Enjoy your lunch, everybody.